Okay, so one thing that we need to think about when thinking about firm production is something called average product, okay? And it's basically defined as the total output, total quantity produced, divided by the quantity of a variable input. So for us, that's going to be labor. So we're really going to be talking about the average product of labor. So basically, if the firm produced 100 units with 5 workers, we would take 100 divided by 5, and that's telling us how much quantity of output is being produced by each worker on average. So that's what average product is. Now, this is going to be important, and average product is different from something called marginal product. And in a lot of ways, it's similar. It looks almost the same in some ways, but it's basically what it's telling us is if we hire one more worker, how much will they produce, right? How much will they add? How much additional quantity of output will they produce if we hire one more worker? That's marginal product. So recall that marginal means additional. Okay, so that's the difference here. It's the output that's created by adding one more unit of variable labor. Both of these concepts are going to be important moving forward. All right, so here we've got the production relationship and marginal product. So we've got, in this column, we've got input of labor, so the number of workers per week, or in other words, number of worker weeks, right? So 1 worker for a week, 2 workers for a week, 3 workers for a week, and so on. And then in the next column, we have total product, which is the total amount of output, the quantity of output that is produced given a certain number of workers. So if there's 1 worker working for a week, that worker can produce 50 units. If 2 workers work for a week, together they can produce 110 units, and so on. Okay, so there's total product. Now average product is right here, so we're just taking total and dividing it by the number of workers. Okay, so this is our variable input, and average product is total product divided by the number of units of the variable input. So here we've got 50, which is just coming from 50 divided by 1. Here the average product is 55, which is 110 divided by 2. Here it's 60, which is 180 divided by 3, and so on. Okay, so again, average product is telling us how much each worker is producing on average. Okay, and then the last one is marginal. So this is just basically the change in total, right? If we're adding one more worker in each row, what does that additional worker give us in terms of additional output? So here it's 50 because we go from producing 0 units to producing 50 units. Then the second worker adds 60 units to output, going from 50 to 110. The third worker adds 70 to output, going from 110 to 180. Okay, so these are basically marginals coming from the differences here, taking the difference in total product. Okay. So that's the relationship between total, average, and marginal product. Now graphically, this is what total product looks like as we increase the number of workers working every week. Output goes up at first, and then it actually starts to decline a little bit when we get out here to the 10th and 11th worker. Now you might be thinking or wondering why output would ever decrease, and basically the idea is that there's so many workers that they're actually starting to get in each other's way and make each other less productive rather than more productive. And so this is kind of the too many cooks in the kitchen story. Here we see marginal product. Okay, so at first marginal product is increasing, and then it begins to decline. Okay, so this is actually where marginal product declines. This is where we're adding workers, and they're beginning to make each other less productive, but each additional worker is still adding or contributing to total output. So when marginal product is positive up here above 0, total product is going up, okay? But once marginal product hits 0, that's actually going to be where total product is maximized. And then once we go beyond that and start getting into a negative marginal product, this 11th worker has a negative marginal product, which means it's actually reducing total output, which is why total output starts to decline here at the 11th worker. Now, we might look at this and you might be curious why marginal product at first increases and then starts to decline. And the logic here is basically that teamwork scenario, right? So at first, these first 3 workers or even the 4th worker, they can come together as a team. They can specialize in certain tasks rather than one person, right, doing all of the tasks. They can sort of separate their tasks and specialize, and there's gains from specialization, just like we saw earlier in the term in Chapter 1. But then at some point, that those benefits from teamwork start to decline, and this is actually coming from the fact that as you increase the number of workers, they're running out of capital, right? They're running out of machines to work on, right? So it'd be like if this was, maybe a software development company, and they only had 4 computers. Well, it would make sense why adding 4 workers, there's an increase in marginal product, but after that, right, there's only 4 computers for these workers to share, and so they start to see a decline in marginal product because they're running out of capital, right? They're running out of machinery to operate on. And in fact, once they get out here, it turns marginal product negative because there's actually, now they're running out of space. And so they're getting in each other's way and hurting output. Okay, so that's kind of the reasoning for why at first we see a marginal product of labor sort of increasing at first, but then at some point it starts to decline. And it's not because additional workers are less qualified. In fact, we're assuming that all of these workers are equally qualified. So it's not because they're, these new workers or additional workers are less qualified, but again, it's because each new worker has fewer machines to work with. And so this is what we call the law of diminishing marginal product. So it's simply the observation that after some point, adding more of a variable input, such as labor, adding it to a fixed factor of production, such as equipment, will eventually result in smaller increases in output. And in fact, at some point, it might even decrease output. And this is an observation that we see in real life so frequently, it's almost impossible to find an example where this doesn't happen. We refer to it as a law. Right, so think about the production of computer servers, or just computers, right? We have a fixed amount of factory space, assembly equipment, quality control software, right? These are our capital inputs. They're fixed because we're in the short run. And so we might add more workers to try to increase output, but eventually they're going to produce smaller and smaller amounts, right? The marginal product of each additional worker is going to get smaller and smaller and smaller, which makes total output go up by smaller and smaller amounts. And at some point, it may even start to go down if we get to a point where there's negative marginal product. Right, so after a while, when all the assembly equipment and diagnostic software are being used, additional workers start to have trouble assembling and troubleshooting problems manually. And the marginal product of an additional worker, given this fixed capital, eventually is less than that of the previous worker. So that's what we saw with the declining marginal product beyond the fourth worker. And so this brings us to this concept of point of saturation, which is just this point where, given an amount of fixed inputs, there's no further possible use, no further positive use for more workers or more variable inputs. So that was the 10th worker, right? Once we got to the 10th worker, that's where marginal product became zero. There's no use for more workers, right? We're basically, our equipment, our fixed inputs, or the firm's fixed inputs, are saturated. Adding another worker doesn't do any good. Okay, so that's the point of saturation. All right, in the next video, we're going to look at short-run costs for the firm.